We're back for more. How's your studying been going, folks? This is Module 4, the next installment. It's a whopper, really big section. So to keep these videos nice and short and consumable, we'll break it in half. So it's around 10 minutes or so per module. As you can see from this intro slide, it is 30 to 35% of the exam. So if I'm going to put a lot of effort in one area, it's definitely going to be in this area, unless you already know how to implement natural language processing solutions, then maybe you want to dig in other areas, but this one's really important. So let's give you the big picture overview before we dive in. Natural language processing supports applications that can see, hear, speak with, and understand users. Using text analytics, translation, and language understanding services, Microsoft Azure makes it easy to build applications that support natural language. Natural language processing, or NLP solutions, use language models to interpret the semantic meaning of written or spoken language. You can use the Language Understanding Service to build language models for your applications. Azure AI Language is a cloud-based service that provides natural language processing features for understanding and analyzing text. So we want to use this service to help build intelligent applications using the web-based Language Studio, REST APIs, and client libraries. Key phrase extraction is the process of evaluating the text of a document or documents and then identifying the main points around the context of the documents. Key phrase extraction works best for larger documents. Note that the maximum size can be analyzed is 5,120 characters. As with language detection, the REST interface enables you to submit one or more documents for analysis. Named entity recognition identifies entities that are mentioned in the text. Entities are grouped into categories and subcategories, for example, person, location, date, time, or organization. The graphic represents the supported name entity recognition, or NER, entity categories, and entity types from the Azure Docs. Here's another chance to pause the video to review the list. I'll also provide the links in the overall links that we will have in the notes. Sentiment analysis is used to evaluate how positive or negative a text document is, which can be useful in various workloads. For example, evaluating a movie, book, or product by quantifying sentiment based on reviews. Prioritizing customer service responses to correspondence received through email or social media messaging. When using Azure AI Language to evaluate sentiment, the response includes overall document sentiment and individual sentence sentiment for each document submitted to the service. So, for example, you could submit a single document for sentiment analysis as shown in the graphic. The response from the service might look like this picture on the right, which has sentiment values. Sentence sentiment is based on confidence scores for positive, negative, and neutral classification values between 0 and 1. Language detection is one of the features offered by Azure AI Language, a collection of machine learning and AI algorithms in the cloud for developing intelligent applications that involve written language. Language detection is able to detect more than 100 languages in their primary script. In addition, it offers script detection to detect supported scripts for each detected language according to the ISO 15924 standards for a select number of languages supported by the Azure AI Language Service. To use this feature, you submit data for analysis and handle the API output in your application. Analysis is performed as is with no added customization to the model used on your data. PII detection is one of the features offered by Azure AI Language, a collection of machine learning and AI algorithms in the cloud for developing intelligent applications that involve written language. The PII detection can identify, categorize, and redact sensitive information in unstructured text. For example, things like phone numbers, email addresses, and forms of identification. Azure AI Language supports general text PII redaction, such as conversational PII, a specialized model for handling speech transcriptions, and the more informal conversational tone of meeting and call transcripts. The service also supports native document PII redaction, where the input and the output are structured document files. Just like with language detection, you can submit data for analysis and handle the API output in your application. Analysis, again, is performed as is with no added customization to the model used on your data. Next, we're going to take a look at process speech by using Azure AI Speech. There's three broad categories: implement text-to-speech, implement speech-to-text, and improve text-to-speech using speech synthesis markup language, or SSML. Text-to-speech enables application tools or devices to text into human-like synthesized speech. The text-to-speech capability is also known as speech synthesis. It can use human-like pre-built neural voices out of the box, or create a custom neural voice that's unique for any particular use case. Text-to-speech uses deep neural networks to make the voices of computers nearly indistinguishable from the recordings of people. I'm not too sure about that, but you can usually tell. But anyways, with the clear articulation of words, neural text-to-speech significantly reduces listening fatigue when users interact with AI systems. The patterns of stress and intonation in spoken languages are called prosody. Prosody? I don't know. I'll call it prosody. Examples of how neural voices can be used include making interactions with chatbots and voice assistants more natural and engaging, converting digital text such as ebooks into audiobooks. We love those. Enhancing in-car navigation systems. Azure AI Speech Service offers an advanced speech-to-text capabilities. This feature supports both real-time and batch transcription, providing versatile solutions for converting audio streams into text. Real-time speech-to-text transcribes audio as it's recognized from a microphone or file. Custom speech is another core feature used to evaluate and improve the accuracy of speech recognition for applications across real-time speech-to-text, speech translation, and batch transcription. The batch transcription API is something you've probably experienced in Microsoft Teams. It's well suited for the transcriptions, captions, subtitles for live meetings, identifying and distinguishing between different speakers in the audio. A lot of times I'll get the notes and it will say Mark said this and Bob said this. Pronunciation assessment, so evaluating and providing feedback on pronunciation accuracy. Call center agents assistant, where they get real-time transcription to assist customer service representatives. Dictation, transcribing spoken words into written text for documentation purposes, and even voice agents, enabling interactive voice response system to transcribe user queries and commands. Real-time speech-to-text can be accessed via the Speech SDK, the Speech CLI, and the REST API, allowing integration into various applications and workflows. Real-time speech-to-text is also available through the Speech SDK, Speech CLI, and the Speech-to-Text REST API. So you can improve text-to-speech output with SSML, or Speech Synthesis Markup Language. I want to make this point also. I'm giving you acronyms, but on tests, they usually always have to spell those out. So you never get a question with just the acronym. I'm just helping you out with that for the documentation. So a little more detail on SSML, or Speech Synthesis Markup Language. It's XML based, which is used to customize text to speech output. So with the SSML, it's pretty cool. You can adjust pitch, add pauses, improve pronunciation, change the speaking rate, adjust the volume, and attribute multiple voices to a single document. You can also use SSML to define your own lexicons or switch to different speaking styles. With the multilingual voices, you can also adjust the speaking languages via SSML. To improve the voice output for your scenario, see the article Improve Synthesis with Speech Synthesis Markup Language and Speech Synthesis with the Audio Content Creation Tool. Again, these will all be included on my blog, where I had listed out all the resources used to help prepare for this on my website. Custom Neural Voice, or CNV, is a text-to-speech feature that lets you create a one-of-a-kind, customized, synthetic, and natural sounding voice for your applications using human speech samples as training data. It's based on the neural text-to-speech technology and the multilingual, multi-speaker universal model. To create a custom neural voice, you use Speech Studio to upload the recording audio and corresponding scripts. You train the model and deploy the voice to a custom endpoint. The custom neural voice consists of three major components. First, the text analyzer, the neural acoustic model, and the neural vocoder. To generate neural synthetic speech from text, text is first input into the text analyzer, which provides output in the form of phoneme sequence. A phoneme is a basic unit of sound that distinguishes one word from another in a particular language. A sequence of phonemes, that's phoneme, in case you're curious, defines the pronunciation of the words provided in the text. Next, the phoneme sequence goes into the neural acoustic model to predict acoustic features that define speech signals. Acoustic features include the timbre, the speaking style, speech intonations, and stress patterns. Finally, the neural vocoder converts the acoustic features into audible waves so that synthetic speech is generated. An intent is something the user wants to do, book a flight and check the weather, or make a call. With intent recognition, your applications, tools, and devices can determine what the user wants to initiate or do based on options. You define user intent in the Intent Recognizer or Conversational Language Understanding or CLU model. The Speech SDK provides an embedded pattern matcher which should be used if you're only interested in matching strictly what the user said. These patterns match more aggressively than the CLU or Conversational Language Understanding, which enables users to build custom natural language understanding models to predict the overall intention of the incoming utterance and extract important information from it. The CLU is available in your favorite languages of mine, C++ and C#. But both a speech resource and language resource are required to use the CLU with the Speech SDK. The speech resource is used to transcribe the user's speech into text, and the language resource is used to recognize the intent of the utterance. To balance accuracy, latency, and computational complexity, keyword recognition is implemented as a multi-stage system as shown here. Generally, virtual assistants are always listening, and that's scary. Audio is only processed if the stage prior to it recognizes the keyword of interest. Keyword recognition acts as a privacy boundary for the user and as a gate that prevents unrelated user audio from crossing the local device to the cloud. I got to be a little skeptical about that. I don't know about you, but when my daughter talks about her favorite shoes and then it appears on my phone, I think it's always listening, but for the exam, it's not. Custom Translator is a feature of the AI Translator service, which enables enterprises, app developers, and language service providers to build customized neural machine translation, or NMT systems. The customized translation systems seamlessly integrate into applications, workflows, and websites. Translation systems built with Custom Translator are available through the Microsoft Translator API version 3. The same cloud-based service, secure, high performance, and system powering billions of translations every day. Microsoft Translator released the Neural Machine Translation in 2016, which had major advances in translation quality over the industry standard Statistical Machine Translation, or SMT technology. Because NMT, or Neural Machine Translation, better captures the context of full sentences before translating, it provides higher quality, more human-sounding, and more fluent translations. Custom Translator provides NMT for your custom models, resulting in better translation quality. If you don't have time to walk through the quick start for the Custom Translator, at least read through the doc to understand the process summary as listed in this graphic here. Publishing your model in the orange chevron makes it available for use with the Translator API. A project might have one or more many successful trained models. You can only publish one model per project. However, you can publish a model to one or more multiple regions depending on your needs. After publishing your custom model, you can access it with the Translator API by using the category ID parameter. Use the category ID when making a custom translation request via Microsoft Translator Text API version 3. The category ID is created by concatenating the workspace ID, project label, and category code. Use the category ID with the text translation API to get custom translations, which will look like this. There are 3 headers that you can use to authenticate your subscription. The table here describes how each is used. Pause the video now to review these. By using the Speech SDK or Speech CLI, you can give your applications, tools, and devices access to source transcriptions and translation outputs for the provided audio. Interim transcription and translation results are returned as speech is detected, and the final results can be converted into synthesized speech. To set the environment variables for your speech resource key and region, open a console window and follow the instructions for your operating system and development environment. And note, on the exam, you will choose that environment, so make sure you know which one you're going to prepare for. To set the speech_key environment variable, replace your -key with one of the keys for your resource. To set the speech_region environment variable, replace your -region with one of the regions for your resource. After you add the environment variables, you might need to restart any programs that need to read the environment variables, including the console window. To call the speech service by using the Speech SDK, you need to create a speech translation config instance. This class includes information about your subscription, things like your key and associated region, endpoint host, or authorization token. One of the common tasks of speech translation is specifying the input or source language. In your code, interact with the speech translation config instance by assigning it to the speech recognition language property. Another common task of speech translation is to specify target translation languages. At least one is required, but multiples are supported. After you create a speech translation config instance, the next step is to initialize Translation Recognizer. When you initialize Translation Recognizer, you need to pass it into your speech translation config instance. The configuration object provides the credentials that the speech service requires to validate your request. To translate speech, the Speech SDK relies on a microphone or an audio file input. Speech recognition occurs before speech translation. The Translation Recognizer object exposes a recognizing event for event-based. In scenarios where you want to output in multiple languages, the speech service directly offers the ability for you to translate the input language into 2 target languages. This enables them to receive 2 outputs and share these translations to a wider audience with a single API call. If more output languages are required, you can create a multi-service resource or use separate translation services. If you need translation into more than 2 target languages, you need to either create an Azure AI service resource or utilize separate translation services. For part 2 of this, make sure you take a look at the speech to text quick start also. Take a look at the configurable options to select. We covered many of these earlier in the series. The difference in this part of the exam is knowing how to translate, whereas the other part of the exam looks similar but focuses on implementing these services. All these resources will be in the notes for this recording, as well as the series for AI-102. That, folks, is half of this section. It's a very large module. I went over my 10-minute limit here, but we have part 2 coming right after this. Good luck to you.